Hi everyone, so welcome back to my channel Mathematic Girls Party 3226. I'm back with my another video, and yes, this video is basically for those who are currently in class 12. So this is a topic of matrices, class 12 topic, chapter 3. And in this particular video, I'm going to actually cover all the NCERT exemplar questions because we are having the solutions for all the exemplar questions in the NCERT book, but still there are some questions, even if we are having the solution, we don't understand it. So that is why I thought of doing the exemplar questions as well, to make you understand if you have any doubt in any of the questions. So yes, let's get started with the video. And this is the first question. So we need to construct a matrix A. Aij 2 by 2, of course, we have to make a 2 by 2 matrix whose elements Aij are given by Aij is equal to e raised to 2ix sine jx. So the very first thing I want to tell you before I start making the solution, that I have already made a video on matrices where I have covered all the basic things, every single thing. I have made, few videos on matrices. So I'm going to put the link of all those videos in the description box, and you can just watch the videos according to your preferences. So let's get started with this one. Here I'm just going to solve it, okay, of course, with the explanation as well, but not in a very detailed way, because that I have already explained in my other video. So that is why I'm going to put the link in the description box. All right, so the first matrix, we have to construct a 2 by 2. So of course, this is going to be a 2 by 2 matrix, only two entries, two in the first row and two in the second row. So we have given Aij by e raised to 2ix sine jx. So the very first entry we have is A11. This one will be A12. This one is A21 and this one is A2. Again, why? I have already explained. So A11, that means I is also and J is also 1. So e raised to 2, I is 1. So 1 into x is x only, so x. And this will become sine. J is 1, so 1 into x is x, so sine x. This is the first entry. So I can put here the final answer. So A11, that is e raised to 2x sine x. Next one we have is A12. That means I is 1. So e raised to 2x again. But j is, okay, 1 second. It's A, okay. But j is 2 here. So this will become sine 2x. J is 2. That is why the second entry is e raised to 2x sine 2x. So the first row is done. Okay, this is called the first row and this is the second row I'm going to write down. And that will be A21. What is the meaning of A21? I is 2 and j is 1. So this will become e raised to 2 times 2 times x. That will become 4x. And j is 1, so it is sine x only. So this will become e raised to 4x sine x. Now next we have a raised to 2. That means both are 2 only. So of course e raised to 4x, because 2 times x is 4x. And this will also become sine 2x. So this is our last entry. Yeah. So e raised to, 1 second. So this will become e raised to 4x sine 2x. And that's your answer. So this is the answer of the first question. All right, now let's move to the second question, and that is, so if A is equal to 2, 3, 1, 2, B is equal to 1, 3, 2, 4, 3, 1, C is 1, 2, and D is 4, 6, 8, 5, 7, 9, then which of the sums are defined? Okay. So the very first thing that I'm going to do is I'm going to write down the order of all the matrices. So the first matrix, that is A. How many rows do we have? We have 2 rows. And how many columns do we have? We have 2 columns. So what is the order? The order is always number of rows cross number of columns. So the order is 2 by 2. Now for B, how many rows do we have? We have 2 rows only. But how many columns? We have 3 columns. That's how we find out the rows and columns also. So of course, this will become the number of rows we write first. So this will become 2 by 3. Now here, how many rows do we have? We have 2 rows and 1 column, so 2 by 1. Here, how many rows we have? 2 rows and 3 columns, so 2 by 3. Now the first question is A plus B, right? Is it defined? That is what we have to check. So A is 2 by 2 and B is 2 by 3. To add any two matrices, we should have the order same. And of course, here the orders are not same. That is why A plus B is not defined. Okay. Let's move to the next one, and um, that is B plus C. So the order of B is 2 by 3 and the order of C is 2 by 1. Again, they are not having the same order. That is why they are not defined. Next, we have C plus D. Let's write down C plus D. So the order of C we have is 2 by 1 and the order of D is 2 by 3. Again, they are not having the same order, so they are not defined. Now, the last one is B plus D. So the order of B, we have 2 by 3 and the order of D, we have 2 by 3. Finally, we got, the matrices whose orders are same. That is why, of course, they are defined and this is the correct answer. Okay. So this is the second answer. Now let's go to the third question. Third question is quite theoretical, but the proof is very, very simple. So the third question says, the third example says that, show that a matrix which is both symmetrical and skew symmetrical is a zero matrix, right? So first of all, let us understand what is the meaning of symmetrical and skew symmetrical. Symmetrical meaning like a matrix is symmetric. That means A is equal to A raised to T. What is the meaning of T? Transpose. Now, what is the meaning of transpose? I'll make you understand. For example, if I have A, B, C, D, E, F, this is the matrix A, and I want to find out the transpose of this. So the transpose will become the number of rows. The rows will become columns. So this is the first row. This first row in the transpose will become the first column. So this will become ABC here. And the second row will become the second column. So that is D, E, F. Now, the next thing I want to tell you here is the entries we know. This is A11, this is A12, this is A13, this is A21, this is A22, and this is A23, right? Here, that entries has actually become A11. Here, A12 has come. Here, A13 has come. Here, A21 has come. Here, A22 has come. And here, A23 has come. So, if I just talk about, Aij, right? Ith entry and the ith row and the jth column, that is actually same as A raised to Ji, right? Of course, that is the same thing. Now, this is called symmetric matrix. Now, next is skew symmetrical. Skew symmetrical matrix is A is equal to minus A raised to T. That means, of course, the entries are like this only, like the first row is becoming first column, the second row is becoming second column with a negative sign. So this is a definition of symmetrical matrix or symmetric matrix. And this is a definition that is Aij will be equal to minus of Aj. Of course, the minus sign is only getting added in this one. So there will be just a minus sign that will be, that I will add here. Okay, so this is called skew symmetric matrix. All right. Skew symmetric matrix. Now, let's start with the proof. This was just the explanation. Now I'm going to start with the proof. And for the proof, I'm just going to write down some, statements as well, just to make you understand. So I'll start with a solution. And yeah. So the very first thing that I'm going to do is I'm going to take a matrix. Let A is equal to a matrix Aij, be a matrix which is both, because that is given, right? We need to prove. Okay, let's read the question once again. So for that, 1 second. Okay, so the question was, show that a matrix which is both symmetric and skew symmetric is a zero matrix. Okay, so that means it is already given that the matrix is symmetric and skew symmetric both. So I'm just taking that into consideration. Let A is equal to Aij be a matrix which is both symmetrical or symmetric and skew symmetric, which is both symmetric and skew symmetry. All right. Okay, so of course, if the matrix is symmetric, so I can write down, since I have taken that into the consideration. So this actually implies, because A is a symmetric matrix, so I can write down A is equal to A transpose. And what is the meaning of A transpose? That means Aij is equal to Aji, that I can write down. Now, also it implies, because I have taken that the matrix A is skew symmetrical as well. So A is equal to minus A transpose as well, right? That means Aij is equal to minus Aji. That also I can say, right? So here I'm taking this into like as a first case and this as the second case, right? Now what I'll do is, from the first case, of course, it is given that Aji is equal to Aij. So from this first equation, okay, from the first equation, in the second equation, I will write down this Aij as it is, minus sign as it is, but at the place of Aji, I can write down this Aij because that is equal to Aji. So I'm just replacing it with Aij from the first equation, right? Now what I'll do, I'll shift this minus Aij to the other side. So this Aij as it is, and this minus Aij will become plus Aij is equal to 0. Now what is Aij plus Aij? Of course, 2Aij is equal to 0. Now 2Aij is equal to 0. That means Aij is 0 divided by 2, which is 0 only. And what is this Aij? Aij was our matrix. So we got A is equal to 0. That means the matrix is 0. And that is what we wanted to prove. Hence, proof. So of course, if you want, you can add a line here that because we have got Aij 0, so Aij is 0 for all I and j, hence A is a 0 matrix. All right. So this was our third solution in Ncert Exemplar. Now we will go to the fourth one. Okay. So let's have a look at the fourth question. So this is our fourth question. Very simple question. If 2x3, okay, so here we have the product of matrices. So 2x3 and then 1 minus 320x, it is equal to 0. Find the value of x. So this is very simple. We simply have to multiply these matrices and we will get the answer. Okay. So let's start with this. So I'll just do the product of these and these matrices first. Again, I have explained how do we do the product of the matrices. So if you want to watch how to do the same, please refer to the description box, refer to all the links in the description box. So 2x will get multiplied with 1. So 2x times 1 is 2x. And then first row with the first column. And 3 times minus 3 is minus 9. This is the first entry. Second entry will become 2x times 2. That is, of course, 4x. And 3 times 0 is 0 only. So yeah, that is it. And then the next entry is x8. And of course, we have this is equal to 0. Now here, how can we multiply? Of course, we will multiply the first row with the first column, and that is it. So 2x minus 9 times 8. So I'll just write down 2x minus 9 times x. And the second entry will be 4x. Of course, we have to add here. So 2x minus 9 times x plus 4x times 8, that is 32x, is equal to 0. Right? So now we can remove this bracket and we can simply equate it. So if we simplify this, of course, 2x into x is 2x squared, minus 9 into x is minus 9x, plus 32x equals 0. Now 2x squared as it is, minus 9 plus 32 is like 32 minus 9 is simply 23. So this will become plus 23x equals 0. Here what I can do is I can take x common. If I take x common, it will be 2x plus 23. Now, of course, you can see that we are having the product of two terms, 0. What are the two terms? X and 2x plus 23. They are getting multiplied. So the product of these two terms are 0. Now, there is one thing in the product of the two terms, that if the product of two terms is 0, that implies either the first term is 0 or the second term is 0. Therefore, it simply implies either x is 0 or 2x plus 23 is equal to 0. We wanted to find out the value of x only. So we got the first value of x, that is 0, or the second value is going to be 2x equals 0 minus 23, that is minus 23. So x will be equal to minus 23 over 2. And this is the answer. Okay. All right, so this was our fourth solution. Let's move to the next question. So we have the next question, that is, if A is a 3 by 3 invertible matrix, then show that for any scalar k non-zero, Ka is invertible and Ka inverse is given by this. So I want to tell you here one thing, that a matrix is said to be invertible. For example, A as a matrix. So this A is said to be invertible if the multiplication of the product of this matrix with its inverse will be equal to 1, or we can call it as an identity matrix. Okay. So 1 or I. Okay. So we just need to check this only. So we need to first check whether Ka is invertible. We need to prove it, right? So we need to prove that K is invertible. K is non-zero, so of course K we can put it in the denominator as well. So of course I need to satisfy this condition. If this condition gets satisfied, then of course my answer is correct. So let us take A as a matrix Ka, right? So according to this definition, A inverse should be equal to 1, right? So let us put the value of A, that is Ka, and times A inverse. What if A is this? What will be A inverse? A inverse will be this Ka whole inverse. Now, what is the meaning of Ka whole inverse? K inverse is 1 upon K. Of course, we can keep 1 upon K because K is a non-zero, that is given. And A inverse is A inverse only, right? So this times 1 upon K, A inverse. Now, of course, we can write it like this, K times A times 1 over K times A inverse, right? Sorry, times A inverse. This is nothing. So this will become this K, and 1 upon K is basically 1 only, right? And this is A times A inverse. So if you just check A into A inverse, it is actually going to be A times 1 upon A only, and that is 1, or that is I. So that is why we got A times A inverse as 1 or I. That proves that this Ka that we have taken for A, that is invertible. Hence, proved. And because it is invertible, so the product of this and this is coming 1. So of course, the product of this and this is coming 1. That means we can also write down this in that form. How? So let's write down, since Ka times 1 upon Ka inverse is equal to 1. This implies if I shift this K to the other side, so that will become 1 upon this 1 upon Ka inverse as it is, and this K I'm shifting to other side. So of course that will become 1 upon Ka. That is same as Ka raised to minus 1. So hence proved, and that is also done. Now let's move to the next question. This is the next question, and I want to tell you here something, that in this particular video I'm going to cover all the short questions. Because we have basically two types of questions, short and long. So in this particular video, I'm going to cover the short answer type questions only. And in my second video, so I'm going to make another part of this video as well. And that will be, like full of all the long questions. So let's move to this one. And this is like this says, if A and B are square matrices of the same order, then A plus B into A minus B is equal to. We all know a very famous formula that A plus B into A minus B is A square minus B square. But here it is not that. So don't get confused and put option A. That is not correct. Let's see why. So here A plus B into A minus B, we are going to use first of all distributive property. So of course this A will get multiplied with this entire A minus B. So A into A minus B plus this B will get multiplied with entire A minus B. So plus B times A minus B. Now, of course, we will use the distributive property and we'll multiply again. So A into A is A square, A into B is AB, plus B into A is BA, plus into minus is minus, B into B is B square. Now, the very first thing that we can do is we know that XY is same as YX, right? So if we have XY minus YX, we can write down 0. But in matrix, it is not the case. In matrix, the product of A and B is not equal to B and A. That is why here minus AB plus BA will not get cancelled. They are going to be as it is. That is why the answer will become A square. I'm writing this minus B square here, plus BA and then minus AB, which is in the option B. Option A is of course not correct. In option B, no, not correct because the signs are different. Option D, A square minus BA, but we are getting here plus BA, so not correct. And C, that is A square minus B square plus BA minus AB. So option C is the correct answer. So option C is the correct choice. Okay, so this was a multiple choice question. Let's move to the next question. This is the next multiple choice question. If A is equal to 2 minus 4 minus 1, 5, 3, 1, and B is equal to 2, 3, 4 minus 2, 1, 5, then only AB is defined, only BA is defined, AB and BA both are defined, AB and BA both are not defined. What does it mean to be defined and not to be defined? It simply means whether you can do the product or not because it says AB or BA. So the very first thing that I'll do here is I'll write down the order of matrix A. How many rows? 2 rows. How many columns? 3 columns. So 2 by 3. How many rows? 3 rows. And how many columns? 2 columns. So remember one thing. If a matrix A has an order M cross N and B has an order N cross B, that means whatever number of columns we have in A, that should be same in the number of rows. Okay, in the matrix B. Then we can find out the product of A and B, that is AB, and the resultant of this matrix is going to be the order of this and this. That means M cross B. So let's check here. We have A 2 by 3 and we have B 3 by 2. Of course, AB, if you want to find out, we can see that this and this are same. So the resultant will be AB, that is the matrix is going to be 2 cross 2. This 2 and this 2. So that means AB is defined. That means A we can say correct. But we have another choice that BA also we have to check. So let's write down now BA. So BA is 3 by 2. Sorry, B is 3 by 2 and A is 2 by 3. Again, if I can see the number of columns in B, that is 2, is same as the number of rows in A. Again, that is getting satisfied. So therefore, if you'll find out BA, the resultant will be this 3 and this 3. So 3 over 3. That means we can say here that AB is also defined and BA is also defined. Again, what is the meaning of being defined? It simply means we can find out the product of A and B also matrices and B and A as well. So that is why the correct option is option C. All right, let's move to the next question. This is the next question. The matrix A is dash, scalar matrix, diagonal matrix, unit matrix, square matrix. So first of all, I'll tell you about a square matrix here. What is the meaning of square matrix? Square matrix simply means the number of rows should be equal to the number of columns. Of course, that is getting satisfied here. But let us check about the other options as well. What is a unit matrix? A unit matrix is a matrix in which the diagonal entries, okay, in which the diagonal entries are 1, 1. Okay, here of course we do not have the diagonal entries as 1, 1. That is why it is not a unit matrix, so not correct. Next is a diagonal matrix. What is a diagonal matrix? A diagonal matrix is a matrix in which the diagonal entries are non-zero. That means all the diagonal entries has to be a non-zero number. But here this is 0, this is 0. This is correct, 5. But this and this are 0. That is why it is also not a diagonal matrix. The next one is, it is a scalar matrix. What is a scalar matrix? Scalar matrix is that matrix in which the diagonal entries are throughout same, right? So here, of course, they are not same. One is 0, 5, 0. They are not same. That is why it is also not a scalar matrix. But of course, it is a square matrix because it is having the number of rows, that is 3, and the number of columns, that is also 3, equal. That is why it is a square matrix. That is why option D is correct. All right, so this is it. Now we can move to the next question. This is our next question. Again, multiple choice questions. So we need to check which is the correct option. If A and B are symmetric matrices of the same order, then AB minus B, sorry, AB transpose A, B transpose minus B, A transpose is a skew symmetric, a null matrix, a symmetric matrix, or none of these. So let's do one thing. Let's write down this. AB transpose minus BA transpose, right? So what I'll do here is I need to check whether it is a symmetric or skew symmetric, right? So we know and null it also. So let us talk about symmetric and skew symmetric. We know that if A is equal to A transpose, remember here this symbol is also a transpose symbol. So if A is equal to A transpose, it is a skew symmetric, it is a symmetric matrix. If A is equal to minus A transpose, it is a skew symmetric matrix. So let us imagine instead of using A, I'm just going to use some other alphabet so that you can understand it properly. So I'm going to use it as C. Okay. So if C is equal to C transpose and C is equal to minus C transpose, skew symmetric, and the first one is symmetric. So let us take this as a metric C, right? So what I'll check is I will just do the symmetric of this. Okay. And if I'll get, because I'm doing this, if I'll get this, that means it is a symmetric matrix. Okay. If I'll get a negative of this, that means, of course, this is also a skew symmetric only. So I'll get a negative of minus, it will be a skew symmetric matrix. And if it will come 0, then it is a null matrix. Otherwise, let's see. So what is the meaning of C transpose? C transpose is basically AB transpose minus BA transpose whole transpose. So this is what I need to find, and I need to check whether I'm getting C or minus C. This is what I need to check, or I'm getting 0. So the very first thing that I'm going to do is I'm going to distribute this, transpose. That is the property. So AB transpose, it will become whole transpose minus BA transpose and then whole transpose. Now there is a formula, and that says if we have AB transpose, whole transpose, that will be equal to B transpose, A transpose. That means this will come before and then this will come later. So simply using this, it will become B transpose, that is this, because it is already transpose there. So that transpose, whole transpose, and then A transpose. Minus, this will become A transpose, transpose, and then of course B transpose. How did I do this? By using this formula. Okay. Now, what is the formula of A transpose, transpose? When we have a transpose of transpose, both the transpose gets cancelled and we'll get just A. And a very nice proof, you can take a matrix, you can do the transpose of it, you will still get another matrix. If you do the transpose of that matrix once again, you will see that you will go back to your original matrix. That is why A transpose, transpose is A. So B transpose, transpose will become B, A transpose as it is, minus A transpose, transpose will become A, and B transpose as it is. Now here what I can do is, I will take this negative sign outside. So what I can do, I can write on this AB transpose first and minus this BA transpose. Of course, I have kept a bracket, otherwise it is minus minus plus only. So BA transpose. And now you can see that AB minus BA transpose, right, I have taken as C. So what I have got minus C. So I started from C transpose, as you can see, and I have reached to minus C. So what did I get? C transpose is equal to minus C. That means this condition, which is same as this one only. So it is a skew symmetric matrix. That is why, which is the correct option? The correct option here is not B, not D, not C, but option A. That is a skew symmetric matrix. All right, so this is it in today's video, and I'm going to meet you super soon in the second part of this particular video, in which I'm going to cover all the long questions and little bit more of, fill in the blanks questions as well. So stay tuned for the next video. I'll be meeting you super soon. I know that I was not very active since last few days because I was traveling, and now I'm back to my space. So yes, I'll be regular and I'll be posting my second part of this particular video super soon, latest by tomorrow or day after tomorrow. Thank you so much for watching. Make sure, if you have not subscribed to my channel yet, do subscribe to the channel and do share it with your friends and families as well. And one more thing, that I'm going to put the link of all those matrices video that I have already made initially or previously in the description box. Thank you so much, guys.